Right, hello, everyone. Well, that was nice. Thank you.
Who are you again?
My name is Chromatic, and you can call me that. I want to give a talk about doing things the wrong way. I'm going to preface wrong by saying wrong can mean a lot of things to a lot of people. I take it to mean that it's not the way that I would normally think to do things if I were to think to do them the right way. That doesn't mean that they're imperfect. I mean, they are imperfect. That doesn't mean that they're unworkable because they're workable. That doesn't mean that they're necessarily quick or easy. But it means that I tried to do things not the first way I thought of for various interesting constraints. I believe that all art in the world, anything people create that has a creative component, comes from constraints, comes from conflicts, comes from, can I write this novel without using the letter E in it? Or can I paint a painting that's representational of three-dimensional in a two-dimensional surface? I believe those things help us create great art. I believe those things help us exercise our creativity. In subjects and in areas that aren't entirely creative, like engineering, we have constraints. I want to build this bridge across a river. The river is a certain width. The river is this close to an airport. We have this much money, and this river bridge must contain traffic of this volume and this weight. We have to balance these constraints in engineering. Software is a little more pliable than physical engineering because we get to rewrite the rules of physics to suit us. I mean, obviously, a NAND gate is a NAND gate, and you can ignore the physics of that to your peril, but everything above that layer, we get to decide what reality is. With that said, my experiment the past year and a half or so has been to embrace constraints that I wouldn't necessarily have put upon myself to see what happened, but because I think that could help me make better art. We talk about building software that's good. We talk about building software quickly. We talk about building software on a budget. Those are obvious constraints. Sometimes we talk about building small systems, even though we don't necessarily need to with our gigahertz processors and terabytes of memory and storage, but those are also constraints. Sometimes we wonder, what if this software could scale to millions of simultaneous users? Or what if it could scale to thousands of devices? Or what if we could prove mathematically that parts of the software actually worked as we intend? What if we made the software easy? These are all constraints. They're not all in conflict with each other, not at all times, but they're all constraints we can put on upon ourselves. For my software, the software I've been working on, one of the big constraints is what can one programmer do on his own time cheaply because of the nature of my business. But it's not necessarily your constraint. I mention this only to say I want to get you thinking about maybe doing things the non-obvious way because it could work out better for you. Or in my case, it could work out worse. I want to build stuff cheaply. I don't want to maintain it by investing a lot of my time keeping it running. I want to make it as easy as possible. I want to automate things. I want to make it so that I don't forget to do things. I want this as simple as possible for me, as low a burden on me as possible, so I can deliver value to my customers and clients without going crazy. I might not do these things the same way if I were to do them again. Even having gone through this experience, or even without having gone through this experience, I might choose something differently the next time. These are not the first ideas that came to my head. These are not the strangest ideas that came to my head, but I was deliberately seeking something non-obvious because I thought it might be better. If we always do things the same time, every time, because they're best practices or we've heard they're the best way to do things, we could get stuck in a rut. And sometimes it takes doing something very, very different to help you see the problem differently. You might not choose the same solution as the first one you thought of. You might find out it has fatal flaws too, but it might help you find something that's better overall. My first example, I have a couple of large applications I maintain that are essentially batch processes. For example, we have a document categorization system where we look out for new documents at certain resources. We fetch the new ones. We discard ones that aren't interesting or duplicates. We process them. We look for various pieces of information in them. Does this document contain an image? Does this document contain metadata to classify it? We perform those classifications, then we republish them to various indexes. It's a very simple approach, but it's a real batch process. Find possible documents, add new documents to system, process documents, repeat, etc. It's just a big cycle that keeps going and going. The obvious solution to me to starting something like this was a distributed job queue. Because obviously you can just store stuff in there. It's reliable, it's transactional, you can scale it to a bunch of different machines. I decided instead to represent each of these documents as an entry in the database. There's a column called the state column. And, of course, I have constants that represent each state of a document. So when a document comes in, I say it's an incoming document. I put that in the database. That has implications for how you design the rest of the system. I decided to push this further when I thought about an idea from functional programming, where the idea is you don't change the state of anything, and obviously that's a lie because I have the state table in the database, but ignore that for a second. The idea of functional programming is you have a function. Data comes in, data comes back out. The data you have is immutable, but within that function, it's a black box. You know you put things in. You know you get things out. It's always referentially transparent. In terms of my batch application, you can think of it as a document in the fetch state goes in, and then a document comes out, and it's in the parse state. Or it's in the, I didn't fetch this, it's obviously invalid, so I'm putting it in the invalid state. So the notion is of this pipeline of functions where you can loop over each set of documents in each state as a pipeline. And of course, you're always going to be writing the new state to the database because obviously this is the real world. I have to do I/O at some point. But that's how I structure these applications. It seems to work out pretty well. As part of these batch applications, I usually have a single driver program. In the case of a financial application I've been working on, it's bin/trend share. And so I can run any state of the application by running that driver program. And I give it arguments, lists of states to manage. So for example, update daily would go out, and for the 2,800 stocks in the index, it would fetch their daily states. It would fetch like last sale price. It would fetch, is this still a valid stock on the market, things like that. And of course, I have build site, publish site. Obviously, there are certain orders you want to do these things, but I've structured this in a functional way so that I can say, go ahead and fetch, update daily. Fetch all the stocks that are in the ready for daily update state. If there are none, it does nothing. That's totally fine. It doesn't matter. It's idempotent that way. It's very, very nice. To make this pattern work, I have, of course, the driver program, which parses command line options and does a few little pieces of I/O to make it a nice user interface. I also have a superclass for all of the individual classes or roles that model each stage in the application. So update daily actually has a role called update daily, as you might expect. And this inherits some of the attributes from this superclass. So I have this trend share app class that has an attribute like a database schema. It has some methods like prepare to process and end process. Basically, bookkeeping. But I know that every application stage I'm ever going to write in this application is going to have some of those, possibly all of those methods. It's going to have to do all those things. It's going to want access to a database schema so that it can actually fetch out stocks in particular states. It's probably going to want access to a logging module. It's probably going to be able to want to be able to throw an error, things like that. In the case of trend share, every application state, everything that processes stocks or pages or transactions or notifications has a separate role in the system. So I've organized the system using roles. Each role represents a certain type of behavior. So it's very nicely composed. And the nice thing about this is a little bit of magic in the trend share binary, a little bit of magic in the superclass, and I have a plugin system built around Moose roles. I don't have to worry about using module pluggable to find things. I don't have to worry about registering things with the application. I have a role somewhere in my ink path that fits the right naming convention. I can name it here, and Moose will find it for me. It's sort of a hack using Moose to manage a plugin system for you, but it's worked out pretty well for me. I've been pretty happy with it. The benefit of this is that building a new stage is really, really easy. Now, with that said, I've gone through a couple of designs for these stages. 3 or 4 of these stages at the start look nothing like the 12 stages I have now. I've discovered what's common to all these stages. I've pushed more things into the superclass. I've rearranged things. But I've discovered what, I guess, the pattern my application wants me to build because of the problem I'm trying to solve. The nice thing about this is that because it's not one monolithic program, or it's not a bunch of little programs, because they share all this information, because they're all composable into this one object to which you can apply roles, I can reuse a lot of this code in other little programs. Most of the programs most of the application's behavior does come from that trend share binary, but I can reuse a lot of these components in other little programs, like find me all the stocks that haven't had an update in a week because there's probably something wrong. Their company's been renamed, they've been merged, I have the wrong symbol, the data feed is wrong, whatever. I can reuse a lot of this code because it's designed as reusable components. Because a lot of this is reusable components, I can make the infrastructure to test all this just once. And so my tests have a real natural pattern, too, that follows the design of the application. The design of the application follows what I believe is the design of the problem, how I want to solve it. And so this uniformity all along, it simplifies not only the access patterns, it simplifies not only my way of using it, but it simplifies my way of developing it. And it's really easy to know what goes where. I know if I want to change something in the update daily stage, I go to trend share app role update daily, and it's all there. Now, obviously, I can share information between supplementary roles. I mean, I have a role that is basically has template. And so I have a template toolkit object in there. I set my attributes on that. I set my paths in there. I can share that between these roles. But all these application roles live in individual places. It's a very nice way to mix things up. Except that some behaviors don't fit into this model. For example, if I want a stage in my daily building process where at midnight I run a vacuum on the database, I run a verification of everything in the database, it doesn't really fit that batch processing model where it's get a result set for all of the entities in this particular state, loop over those, perform a behavior, and then see if there's anything else to do and quit. But it still fits into the model well enough. I don't care that my my cleanup database role inherits fetch result set or something like that. I don't care because I don't use it. It's not necessarily classically beautiful but it works well enough in here. I have discovered in this that I've changed my abstraction model a few times. I think the right behavior emerges as you see more behaviors, you find more commonalities between them. What I started out with was okay. It worked. But then I added more things into it. I had to change it. And that's fine. I can afford to refactor these things. What I have now, I think, is very, very effective. With that said, you're always going to want to be very, very careful about duplication in your system. Duplication between names of things, registering things. If you're adding a new stage, you want to make sure you can just add one thing somewhere and it will get picked up automatically. You don't want this duplication in various places. That's a hard thing to find in this case, especially when you know you're going to be refactoring something actively. But by finding a good set of configurations, by finding a great set of conventions you can rely on, and by being very, very careful to let this design emerge, I think you can find something even beautiful. I use this on at least 3 projects. One of them is a document classification system. One of them is a financial analysis site. One of them is a book publishing pipeline. They work beautifully. I think it's more of a pattern than a framework. So I can't really release a bunch of code to the CPAN that says, here's my workflow model, because it's a way of thinking about designing code, because the workflow is going to be different for you. With that said, I think it's a very, very valuable pattern, and I'm going to use it again when I write applications that fit into this batch processing model. Of course, not all applications do, and that's fine. If you have an application where part of it fits something else, like a web interface to this document indexing system, it doesn't make sense to use that, but you can sure use that as part of your application. It works beautifully for that. I'm very satisfied with that. A little more practical. Suppose your problem is you have lots of resources and you don't want to spend a lot of your valuable time waiting for the network, and so you want to fetch multiple resources at once. Obviously, you need something like LWP parallel or www curl. Or you can write out some flat files, fork off a few processes, and use wget, which is what I do. And I'm not really ashamed of that. I think it actually works out very well for me. Because even though LWP and www curl are written at least partly in Perl, I understand job control far more than I understand the nuances of HTTP fetching. I mean, I could understand HTTP fetching, but I don't want to. I understand how to use, Fork Easy or something like that, proc fork, whatever I'm using. I understand that. I understand how to use wait PID. More than that, by breaking this up into fetching with an external process, I can actually fetch these files to the file system and use that as a cache, which I'll talk about a little bit later. As long as I'm careful about managing these processes in a way that anybody who's done process management on Unix successfully before knows how to do, it works out fine. I don't have to have the kind of deep control over the HTTP fetching that I would get from LWP. I don't need control over headers. I don't need control over the timeout, the back off, things like that. wget just works for me. I know it seems really scary to do fork and system, or fork and exec in my case. It seems so counterintuitive, but it works out very, very well for me. Except that in those cases where if I ever really needed control of the HTTP process, I wouldn't have it. It hasn't come up, but with that said, it's said. And with that said, I did have a bug in my wait PID. I was doing something slightly wrong there, so the first time I did this, it hung forever. But I fixed that, and it works now because I understand Unix. I guess really the only problem is that with handing the control over to an external program, you either get a successful fetch or you don't. It's all or nothing. But that's okay because I've designed my application to be idempotent. If something doesn't happen correctly, that's fine. The next time I run through the cycle, I'll try it again. And if it still doesn't work, I'll just put it in the queue that says it's invalid, needs human intervention. So I've had the luxury of designing my application to work around these failures here. If you had to handle these failures in LWP in your loop there, that'd be a different story, and that's a reason to use that. That's fine. But it's worked out fine for me. The nice part about this is that as part of my batch process, I loop through all of the fetchables I need to fetch in the fetch state. I grab the URLs. I write out a handful of different flat files full of wget commands. And I write 3 of those, I think. And then I just fork off 3 wget processes. It's embarrassingly parallel. It uses my CPU just fine. It uses my network time just fine. It works wonderfully. More than that, I've separated the process of finding things to fetch from fetching things and then updating things I fetched. I've broken this pipeline into smaller and smaller chunks. That gives me more fine-grained control over things. It makes things more robust because I have to think about what I actually care about at each stage. On the other hand, like I said before, these fetches are cheap for me. Fetching something 3 or 4 times before I decide to give up on it is fine for me. If you need extreme reliability in these fetches, then this is not the approach for you, and that's fine. Also in these cases, I/O latency is not really the bottleneck for me. It's wall clock time is the bottleneck for me. So I don't care that I'm doing a little more disk I/O, because by doing all these things in parallel, I'm minimizing the time I spend on the clock waiting for these things to happen, because I need to get these things out in less than an hour. So if these are your concerns, that's fine. Don't use the solution. On the other hand, with these batch processes for me, this is absolutely the right solution. Every time I can use this, I can, because I don't have to worry about so much. So much of my code just went away, realizing that something else could handle the parallel processing for me. It was a revelation. And in fact, I have an existing application that uses the www curl approach that I might revise to use this because it is so much nicer this way. It's wrong, but works out really nicely. And if you thought that was wrong, suppose you have to scrape some web pages to get information out of them. And no, I'm not going to say regular expressions. The obvious solutions are to use some sort of HTML parser, or barring that, something that understands CSS expressions that you can get at the data you absolutely need. Okay, but to be fair, most people probably use some really fragile regular expressions and get away with it most of the time. If you're really, really good, you can use something wonderful like template extract and get at the data you need. It's wonderful. It's beautiful. You don't always get to use it. Oh, somehow that went wrong. Okay, instead of doing this, I've already fetched the pages onto disk. Then I run links. You know, the old text mode web browser? It has a command line option called dump. So it's link space dash dash dump that Just one dash? Well, I don't remember what it is. I use a module for that. Anyhow, this extracts all the HTML and gives you just a text format of the file. It works beautifully. And here's the thing. I'm using this for some financial data, which is tabular. You're looking at the past 10 years of financial results for security. That's tabular data. You get back a white space separated list of things. You don't have to worry about how they fall into the table. You don't have to worry about this and that tag or things like that. You get back plain text, and you can just split on white space there. It is so beautiful. It is so, when you look at the code, you say, why in the world are you running this through links? I say, why in the world am I did the regular expression thing for a while. I did the table parsing for a while. I said, there has to be a better way. Why can't I just get this in plain text? Oh, I get it. This is absolutely the wrongest thing you could think of at the start. I didn't even think about it at the start until I realized I was using links to debug what I was getting because I couldn't stand looking at it. So here's the thing. You design to make your life easier debugging these things. You might make your life easier writing these things. I don't know. If you like that, here's something even uglier. I'm fetching these 2,800 stocks every day. I want to change, the start price, the end price. I want to change the price to earnings ratio. I want to change market capitalization. I want to change a handful of things on all these 2,800 stocks. Now, obviously, I'm a good Internet citizen. I'm a good Perl citizen. I'm using DBIX class because it's wonderful for these things. Let me back up a step. DBIX class is wonderful for fetching things. DBIX class is not necessarily wonderful for bulk updating things because it runs a lot of code to do the update, which is fine. Sometimes you want all the validations it does. Sometimes you want its transactional semantics. Some days you want it to run through all your model code, and that's wonderful if you want it that. Me, I know exactly what data I'm getting. I know if I get a web page that's blank, if Link spits back something blank, I'm not going to say that Boeing closed at 0.0 today because I don't believe that's going to happen. It might happen, but if that happens, something is a lot more wrong with the financial market than I can deal with that day. So I've already verified my data makes a lot of sense. So the obvious solution here is to do this fetch and to do the iterator on your stocks and go out and do the fetch the data and look at this and store it in an update and do update in there. And so you think, oh my goodness, that's going to be slow if I have transaction commit on every insert, and that's insert or update, and that's fine. So you wrap the whole thing in a big transaction. Or you write out a bunch of SQL and dump that in your database in one big shot. And yeah, that's about as ugly as it sounds. And so you realize that if you're optimizing for wall clock, and you could get this all done in 30 seconds, while it was otherwise take you 30 times longer, hey, maybe the ugly approach could work for you. There are some optimizations you can do to make DBIX class updates a lot faster, and that's fine. I haven't found those. I'm sure they exist, and I'm sure someone in the audience, well, I was thinking of you. Yeah, a lot of people in the audience could tell me about that, and that's absolutely fine. I don't mind that. I'm open to these things. But I could also make my transaction manager a lot faster, too. Here's my example. Here's my analyze monthly. Line broke nastily. Anyhow, the analyze RS method, it gives me a DBIX class result set full of all of the securities with an analyze state, anything valid that I know I can analyze. I'll talk about the create transaction here in a moment. But you can see the loop. If you've ever used DBIX class for fetching things, you know that iterator loop. And so I obviously do my discounted cash flow projection and figure that all out once a month. And then I execute the transaction. Okay, I create a transaction here. The table is year projection. The primary key of this table is ID. So now I have a transaction. Within my update FCF method, you don't have to know most of this, but I create a hash where the ID is the ID of the current projection. Okay, so I have the primary key all sorted out. I know how to find this object when I want to update it. I do some calculations. Then in my update hash, I say the free cache is now the free cache I've calculated. The present value of that stock, if you don't know finances, don't worry about it. It's a cool concept, but don't worry about it. The present value of that update is now the present value I've calculated. The total worth of this company at this particular year is the total worth I've calculated. And the share value, given that present worth, is this dollars. Okay, all that said, I've made a hash of updates. It's bound to the right object in the year projecting table because I have the primary key set in there. I add that to the transaction object. Within the transaction object, whether it's a transaction object going out of scope or me adding enough transactions to get over a limit of I want to gather 20 at a time or 50 at a time or 100 at a time or every second I dump these all to the database or whatever, I generate some SQL. Where I loop through all the rows in that update hash, and I know that every update hash I've added to the transaction manager has the right primary key for the table because if it's not there, I say, okay, stop. You have bad data here. I'm going to stop this process until some human intervenes. I create a new update statement for every hash I've given there, and it's just a SQL statement. Because I know all of the column names come from this code I've written myself, they don't come from Yahoo Finance, they don't come from Google, they don't come from Morningstar, they all come from code I've written myself. Because all these values come from values I've calculated myself from values I've sanitized, I quote those anyway just to be safe because I'm paranoid. But I just make a raw SQL statement. And I just stuff it in the transaction object, and every 20 or 50 or 100 transactions or whenever something goes out of scope or the program ends unexpectedly, I just write that to the database. That's it. It's as stupid as that, and I can't decide whether I'm more proud or embarrassed to talk about this. But this is at least 30 times faster than DBS class. I'm not nesting transactions on some databases that support that and some databases that don't. I'm not rewriting my code to use callbacks for all this. It's just introducing a layer of abstraction and saying, here's what the updates look like. And here's a funny thing. I can distribute this on multiple machines and gather them all together and just do like updates from 10 machines at once. I can do these on 10 machines in different parts of the country, so I have different network latencies, or I'm not always blocking the same thing or not always taking the same path. It's embarrassingly parallel because I broke the program into the correct components, or at least correct for me. Like I said, I don't know if I'm proud of this, but I'm showing it to you, so I might be. I don't know. This might work for you. This might not work for you. This might be the dumbest thing ever. There might be a switch in DBAS class that does this faster than this, and if so, please tell me. But I like this, I think. I think I like this. I like this in part because the add partial updates to a transaction object seems like a nice pattern. It seems like it makes sense. It seems composable. It seems like it follows that functional program idea pretty well. Within the loop where I'm getting new objects out of my iterator from the result set I'm searching things on, I'm not immediately writing to them. I've separated those out. That feels nice to me. There's a layered design. There's a class for inserts. There's a class for updates. They're different. They share things that make sense. There's a transaction manager that is neither insert nor update, but it handles both of them. I feel like I found a pretty decent design for this. I still don't know if I like this code. I still don't know if I like this approach, but I like the pattern. Assuming that approach makes sense, I like the code I've written to make this work. And again, if your application does a lot of reads from the database, but doesn't do a lot of writes, if writes are something infrequent, like every afternoon, 2 hours after the New York Stock Exchange and NASDAQ close for the day, this could make a lot of sense. For batch updates, infrequent batch updates, this could make a lot of sense because it is so much faster. The time spent updating was almost entirely dominated by writes, and this includes forward projecting and backward projecting values. Yes, Chris?
Just a random question. I'm wondering if you do after-hours trading with this.
He asked if I do after-hours trading with this. I do not. Due to the nature of the site, I'm happy to explain that later, anyone who wants, It doesn't make sense to do after-hours trading. It also doesn't do high-frequency trading because I'm not an amoral bastard. Is this being recorded? My parents were married long before I came about. I'll say that. Yes, Andy.
The other advantage is I do this all the time because production database can't take those inserts. One, it lets you split up the work from part of it here, part of it there. Second, you can visually eyeball the SQL that you're generating, and you can test your own assumptions about what you're generating and putting into the database.
That's exactly right. I actually forgot that. Andy is absolutely right. What I said before about write things that make it easy for you to bug, I originally did this because I wanted to see what data was going in the database, and I didn't want to see the DBIC trace log because that was just too much information. I wrote this so I could see what data I was sending to the database, and then I realized, wait a second, this is a nice pattern. And Andy likes it too, so that's pro or con depending on how you feel about us. But again, also Andy said that his production database can't take this hammering of inserts, and that might be a case for you. For me, I can take my database offline for 30 seconds, do all these updates, put it back online without disrupting anybody's service, and it works really, really well. It doesn't even have to be 30 seconds. This runs in like 2 seconds for 2,800 stocks. It scales really, really well. I mean, obviously you want to wrap it in begin transaction, end transaction to make it go fast, but I just told you the secret, so there you go. Yes?
You're not alone here. I mean, we've done something similar. We have, God forbid, a table in our database where we just insert, and every little process comes back around and takes 100 or so inserts and then runs the updates that we're going to run.
Okay.
So this happens in real life, definitely.
Well, I like to think I'm in real life too, but thank you.
It's ugly. I'm not proud of it, and I think
I don't know if I'm proud of it. I think so too, yeah. I think I'm proud of it. And I don't lay claim to inventing anything here, but I also like to think I've invented something better than maybe Matt's script archive code circa 1998. Question? Comment?
We did something similar. We were trying to insert into a heavily used database,
Mm-hmm.
and we were trying to insert about 4,000 records.
Mm-hmm.
So what we found out with MySQL, if we inserted the 4,000 records into a table that wasn't used,
Mm-hmm.
and then we basically did insert select star
Right.
from the database. Instead of taking an hour to insert those records, it took like 30 seconds. to insert
Exactly.
records.
Right. So the pattern other people are saying is they insert into a temporary table in the database, then do insert into subquery or something like that, which is a fine pattern too. I like writing stuff to files on my disk. I don't know why, but this can work a lot of different ways. I will say this. It took me a little bit of thought to get the design right. It took me a little bit of thought to get the implementation right, but I'm talking a couple of afternoons. And I'm not the world's best coder. I'm pretty good, I think. But it's not hard code to write. Anybody in this room could write this in a couple of days, tops. It's not hard to write. You do have to be a little careful. You do give up some of the transactional semantics of your database if you're writing these files, if you're not careful. So you have to keep in mind what can die, what can end, what can abort, what can do that where. But if you're writing robust applications in Perl anyway, you should be understanding these things. With that said, yeah, I'm duplicating some stuff that's already in DBIS class. I probably shouldn't, but you code for the war you got, not the war you wish you had. I don't know. With that said, if you do have validation logic for things like inserts, you have to be careful about that. Maybe push that into the database level itself, or maybe in that case you want to be more careful about how you use DBIS class. Maybe you want to write out something that does just a big DBIC populate or something like that. If those insert validations are important to you, and they might really be to you if you're not really careful about these things. Yes?
One thing to note, if you want to use DBI directly, the fastest way to do that, I've found, is to use the execute array on the core DBI itself. That will be very, very quick and a lot quicker to do individual statements.
Okay, execute array on DBI itself works pretty well. I'll take a look at that. Thank you. There's also DBI bulk insert, DBIX bulk insert or something like that, a CPAN module that I've seen used pretty well. So you have options there. Yes?
Another possibility for rows arrays and frequent approaches, and I use DBS Place a lot, but if you really need to do something with the rows, if I actually sometimes have to just print out print out a file and use MySQL like as a command line bulk
Right, right. Yeah, a bulk insert tool works pretty well too. That's, I thought about using that too, and I had mixed feelings about adding yet another external file there. You know, it's fast enough for me here, but that is definitely a possibility. So yes, thank you. Again, whether this works for you or makes any sense for you, whether you think we're all crazy for doing this, depends on your data model and your usage. It's not the right solution in all circumstances, but it turned out to be a real benefit for me, at least so far. Here's a fun one. Suppose you're working on something like a website, and you have frequent updates. And calculating some of the information for every new page takes a while, like calculating the discount rate of a particular stock or drawing a nice graph of its historical prices over time or something like that. So the obvious solution is to scale horizontally, add layers of caching. Obviously, you need to regenerate these things, but you don't want to regenerate them all the time, so you throw memcached in there, you throw reverse proxy like Varnish in there. You go to NoSQL, you forget your schemas. Or you say, I'm using Template Toolkit. Why don't you write out Template Toolkits every day? So I write out my own little templates in a templates components cached whatever directory. I write these out once every day. It's really stupid. But it works really, really well. Or another thing I do, if, for example, on the site that has ads on it, we have an ad manager on the admin console, someone changes the ad, I change a symlink. Because we're writing out just static files. There's nothing dynamic about the site at all. It's just static. Okay, there's a search index, and that's obviously dynamic. But the front page of the site, I write it out every 5 minutes based on new stuff that comes in. And I'll just switch the link. And you know what? It serves, Apache will serve, or Varnish, or whatever, will serve a different file based on that symlink. And it works out okay. I don't have to have a little program in the back that says, what ad am I going to serve based on this from the database? Because I'm doing this the dumbest way possible. It's a Unix file system. My web server knows how to work with the Unix file system. I know how to work with the Unix file system. Or here's the worst one. Sometimes I write on an htaccess file to do a redirect to the right URL. I know. I think I'm not proud of that one. I know I'm not sure I'm not proud of that. I'm pretty sure I'm not proud of that one. But it made a lot of sense at the time. I'd fix it. I'd go back and fix it, but it works so well, I'd almost forgotten it was there. So I don't know. The benefit of this, of course, is that the file system, the operating system, they understand caching better than I do. Also, if you have multiple machines, it's a lot easier to synchronize files than it is to synchronize memory. My application, it just works. Includes this component, just works. And of course, I'm not hitting the database, which is probably the bottleneck in a lot of our stuff. Obviously, that's the goal, not hitting the database, but it works out pretty well there. With that said, this optimizes for reads a lot more than writes. A lot more than writes. Orders of magnitude, lots of orders of magnitude. Orders of magnitude more than writes. With that said, generating these little cached template toolkit fragments can be a real pain if you want template toolkit directives in those. I figured it out. It's quoting, but then again, I figured out how to make closures work in the bash shell, so I might understand quoting pretty well. With that said, I don't know how this works with template toolkit caching itself, because I'm generating a lot of little things for it to cache. That might be a bad thing. That might be a good thing. There are ways to prune that. I need to tune that. I don't know. But more than that, you absolutely need to understand how your file system works. You don't want to be writing out something as someone's trying to read it. So that atomicity thing is really, really important. But there are ways to get atomic file updates in Unix, so that works out pretty well. Maybe it makes sense to go to a purely static site with no dynamic components. We have that almost all working on one site, and it works really, really well. Works really, really well for this. But I think it's like functional programming, or it's like immutability. You can take that to a point where it makes sense, and you can take it too far. So don't take it too far. With that said, this is really pretty easy to manage. Once you get your head around what it's doing, once you understand what it's writing, once you get the quoting right, it's easy to manage. And of course, you can have a dynamic fallback. If it's not there, generate it for the user, then write it out to the page. That's fine. It's really simple. I guess the real question is, if you have complexity in your data, if you have complexity in your application, if you have complexity in what your users want you to do, that complexity has to go somewhere. I think a series of layers where you can point at that and say, this goes here, this goes here, this goes there, is the responsible and right approach, even if you have to do things wrong. Finally, suppose you have, let's say this, a luxury wine site. You have clients who are several wineries, and they're boutique wineries because they live in Oregon, and everybody who made money in Microsoft moved to Oregon and started up his winery and sells 800 bottles a year. True story. They want to sell these online in a luxurious, rich client experience that doesn't look like I'm paging through a Sears and Roebuck catalog from 1898 that happens to sell wines. You know, here's a grid of 9 things, hit next, okay, 1 out of 10, 2 out of so forth. No one uses Flash. No one uses applets, and thank goodness for that. And I don't want to use a dynamic site because I'm lazy. HTML5 adds this interesting thing called a data attribute, which means you can stick any old attribute on an HTML5 element, and whatever you put after the data dash is whatever you want. Hey, stuff whatever in there. So I built a database out of these things on the client side. And the punchline is, really. So I have a little bit of jQuery. Someone says, show me only red wines. Okay, I know where to find all the wines in here. Let me just burn through this array of 500 wines, and okay, everything that's not red, hey, it's hidden now. Great. This is really stupid. It was a great proof of concept. It took 2 days to write this. And half of this was just figuring out the right jQuery example I wanted to use. This is amazing because you can hand this to a client on a USB stick, say, go on an airplane, and they can try it out and say, this is great. How did you get this active updates when I was on an airplane? Well, I know a little thing about the web, don't I? This caches on the client side. This pushes all over to the client side. Here's the thing. As stupid as it sounds to be groveling through 500 of these things, how fast is your computer? How fast is jQuery? How fast is doing string matching on these things? We're doing more than that just to render the user interface of Firefox. Let's be honest, right? There's no server-side code here. I mean, I have a database of these wines. I have the database of attributes. I write out this stuff. That's totally fine. But the possibilities on the client side are almost endless. Almost endless. And even the simple version I coded by hand once and repeated, trivial to understand, trivial to modify. It was beautiful. Okay, I did this by hand for about 2 of these wines, and I said, forget this, I know Perl, I'm generating the rest of this. Okay, so there's some dynamicity to this, and that's great, that's fine. You know, writing out this format here is a little bit inflexible. The right approach is probably for me to write some sort of relational database or at least set operation system in JavaScript to which I can feed JSON about these things. I hear myself saying that. Yes, I hear myself saying that. I know how to do it, but I hear myself saying that. But it works so beautifully for the client side. It's a wonderful client experience. I can show this to my sister-in-law, and she says, I'm thirsty for wine now. And she prefers, she's watching this, she doesn't drink wine. But she can have a very nice experience on this. She can enjoy browsing this because it's such a reflexive and responsive interface. It's a beautiful thing. It's not your Sears and Roebuck catalog for wine. It's a wonderful thing. So I think I take the proof of concept I made, I make it a little more robust, I make it a little faster, I make it a little simpler. I obviously want to add more bling to it. Do people still say that with jQuery? I want to add more pizzazz to it. Steve says it, but we're old, so I want to add a little more pizzazz to it with jQuery. If you're into semantic web, these things are brilliant because you can have people scraping your site, and of course the poor links people like me don't get any of this benefit because we don't even see that awesomeness is there. But semantic people can go to this and say, oh, I get it. This is almost a database I can use, which I don't know if you care about that, but if you care about that, you can. But it's really simple to pre-compute this data on the server side, and it works great in combination with the static page generation. With that said, what I've told you, many of you will probably never use except the database thing, which I thought was the worst thing, but some of you like it. So, hey, it might be the best thing. Where you can, find things that are immutable and keep them immutable. Embrace that. Those are your friends. Those are your best friends. Those are the people that will bail you out of trouble. I got to be careful with recording this thing. when you find what's immutable, you can optimize. Optimize for the things that change, and everything else, optimize that because it doesn't change. But more than that, if you're doing crazy, silly things like I am, if you're doing wrong things like I am, be very cautious. Because things will go wrong. And you have to keep in mind that things will go wrong. But if you do that, if you keep things in nice layers, if you keep the immutable, if you optimize the things that change to change, you can put in the points where you think things will fail and catch things robustly. And I think you can design better applications. I'm not suggesting you should do things the way I did them. Maybe this gives you some ideas to do things differently. Maybe this is all just a weird exercise where I was in a bad place for a year and needed to get this out of my system. Time will tell. But I think there are some real gems from doing things the wrong way that we wouldn't necessarily see if we kept doing things the so-called right way all the time. I have time for a few questions.
Something that I wonder what you think about. So embracing the immutable is something that is definitely I 100%. And what about things, perhaps maybe a word on the idempotent?
Okay, so Steve asks, what do you mean by, or can you talk about things that are idempotent?
Well, yeah. What do you think about that? Because I mean, sometimes you have to change things.
Yes.
You want them to be predictable. In the same. I suspect you have, ideas about that.
When I say idempotent, I think, okay, I have my batch document classification system. I want to run fetch documents. I run that, it fetches everything it can. Some stuff goes in invalid, some stuff goes into process document. If I run fetch documents again, guess what? It does nothing. That's totally fine. Every document has gone into one stage or the other. It's reliable. I can run that again as many times as I want. I'm not going to get different results. And if, for example, it stops in the process document stage, there's an error, it starts up, it runs again, it will try to fetch things. Nothing's there to fetch. That's fine. The application works even at various points of failures. And, of course, the fetching depends on timestamps and things like that. So stuff suddenly comes up for fetch. But, it will go on, and there's an error. And, of course, that will stop one particular stage, but everything else will proceed as normal. So the idea is that, I guess, a failure in one piece of data or one piece of the pipeline is not fatal to the whole application. It's not mathematically rigorous definition of idempotent, but I'm not a mathematically rigorous guy. I'm wearing a suit coat with jeans on the plane here, so that should tell you a lot about me, too. Any other questions? Okay, then.
I'll use the time.
Yeah, okay, please.
To build on your static file content approach.
Yes.
One of the tricks I use along those lines is there's a way with mod rewrite to detect that a file's not there.
Mm-hmm.
So you just use mod rewrite to go to a PHP or something to build that cache for the next hit.
Yes.
And that was an way to get sort of basically what you're doing.
Right. Mod rewrite is a nice way. I mean, if you understand mod rewrite. But mod rewrite is a nice way to detect that a file doesn't exist, run something in an to generate it, and then serve it. And that's a very nice caching system. That's a great approach. Yeah, I like that approach, except I don't like mod rewrite. Fortunately, Plaque has a mod rewrite handler, so it works out very nicely that way. Yeah, Plaque does. Last chance. Anything else? All right. Well, thank you for your time and attention.